Hi, today we're going to go over section 2.3 in your grade 11 functions textbook. So this is about factoring polynomials. So in grade 10, you should have learned some skills and techniques for factoring polynomials. In this lesson, you're going to review some of those techniques and learn new ones by combining old techniques together. So this is going to be an overview on the first page of your handout, so follow closely. Pause the video at any point if you need to slow down, rewind to rewatch part of the instructions. So when you're factoring, we are actually writing a polynomial as a product. So instead of it's the exact opposite of expanding or foiling or multiplying out polynomials. So strategies for factoring fully. You should at all times check and look for common factors before you move on to other methods. So a common factor, to identify the greatest common factor in a polynomial, you can follow these rules. First, you will consider the greatest common factor or GCF of the coefficients. What factor or what number can be divided by all the terms in the polynomial? Secondly, you're going to identify the greatest common factor of the variables. And to do this, first you're going to identify the variable that is shown in every single term in your polynomial. And then the one variable or the term with the lowest exponent will give you the greatest common factor of that particular variable. Once you have identified a common factor and common factored your polynomial, you will look at the new factors and then to decide whether you should move on or any of these rules will apply. For example, do you see a trinomials that can be factored? When you factor trinomials, you will be using product and sum, or some of you may be familiar with a method called crisscross, or the special method that some of your teachers might have taught you in grade 10. Or it's your factor a difference of squares. To factor a difference of squares, it will be a squared minus b squared. So difference of squares look like that. And then the pattern will become a plus b times a minus b. Or do you see a perfect squares? Well, the pattern for a perfect square is a squared plus 2ab plus b squared. And then it will become a plus b squared. Or if you see a minus sign in your middle term, then your binomial in factored form will be a minus b squared. And then for polynomials with more than 3 terms, a new method will be introduced in this lesson called grouping. And sometimes you may have to rearrange your polynomial first before you can start grouping and factor. So if you go to the next page on your handout, we're going to go over some of these examples together. So here the solutions are already written, but I will try to walk you over every single step and show you how to factor. So just as a warm-up, in example 1, we're going to determine the greatest common factor of the terms listed here. So refer back to the rule that we just mentioned on the first page if you forgot. So if I have 4x cubed, 6x squared, and 12x, first I will check the coefficients for 6 and 12. The greatest common factor for these numbers is 2. And then we look for the GCF of the variables. Since we have an x or x cubed or x squared in these terms, then for sure x will be part of the GCF. The question now becomes which power of x is the GCF. If you remember the rule, it will be the x with the lowest exponent, which is x. So the overall GCF of these 3 terms is 2x. So move to part B. Take a look at these 2 terms. So I do see an x in both terms. So x cubed will be my common factor. And y to the power of 4, because it says lower exponent, the lower power of y is a common factor. There's no z in the first term, so it will not be part of the GCF. C, 2x times x minus 1 is my first term. 8 times x minus 1 is my second term. So even though x minus 1 is a binomial, well, it is still multiplied to the rest of the term. Therefore, it can be treated just like a variable, even though it's a binomial, and that becomes part of the GCF. And then between 2 and 8, well, of course, 2 will be the greatest common factor. So now you have practiced finding the GCF of polynomial terms or monomial terms. We can apply that in factoring questions. So example 2a. When you look at this trinomial, so there are 3 terms here. Among 12, 4, or negative 4, and 8, 4 is the GCF of the coefficients. I see x cubed, x squared, x cubed again. So x squared is part of the GCF. y4, y to the power of 2, y to the power of 5, y to the power of 2 becomes part of the GCF. So overall, the greatest common factor is 4x squared, y squared. And now how do we determine the rest of the terms in factoring? What you will do is you take each term now and divide that term by your greatest common factor. So divide 12x cubed y to the power of 4 by 4x squared y squared. You will get 3x y squared, just like that. Second term, negative 4x squared y squared divided by 4x squared y squared. That will be negative 1. You repeat this step, so 8x cubed y fifth divided by 4x squared y squared. You are going to get plus 2x y cubed. Question B. 2a times 5b minus 1 minus 4 times 5b minus 1. You have one big term here, 2a times 5b minus 1, and the second term, negative 4 times 5b minus 1. So apparently, 2 and 4, the common factor is 2. I also see the binomial 5b minus 1 and 5b minus 1 in both terms. So automatically, 5b minus 1 becomes part of the GCF. So when you look at the solution here, 2 times 5b minus 1 is the entire greatest common factor. Then what's left? Well, compare the GCF to your first term. Divide the first term by your GCF, you have 8. Divide your second term by the GCF, you have negative, it should be a 2 here. Okay, so I'm going to correct this when I post this. Then we have trinomials. First, I see 2, negative 16, 30. The common factor is 2. Then, you common factor 2, you have x squared minus 8x plus 15. This is a trinomial. In grade 10, you learned that to factor a trinomial, you need a product and a sum. Product is your constant term, 15. The sum is the coefficient of the x term, negative 8. So which two numbers, when you multiply together, will give you 15 and give you a sum of negative 8 when you add them together? That's negative 5 and negative 3. So the factored form of this trinomial will be x minus 5 and x minus 3. So these numbers goes into each of these brackets. And then don't forget you have the 2 over here. Well, let's move to the next trinomial. 8, negative 10, and 3. I have no common factor. So now the leading coefficient, the coefficient of your y squared term, is 8. When the leading coefficient is not 1, then your product will be slightly different from the last question. Your product will be 8 times 3. So which two numbers will multiply to give you 8 times 3, or 24, and add up to -10? That's -6 and -4. But you cannot use these numbers directly yet. You need to give it some special treatment. The way some teachers might have taught you last year is this. Take your leading coefficient and put it as a numerator of a special fraction. You do it twice. So 8 over something, 8 over something. Well, what are the something? The something are these two numbers, so -6 and -4 that you've just found. And then you will try to simplify these so-called fractions. So 8 and -6 can be divided by 2 each, so 4 and -3. And then 8 and -4, well, you can divide both numbers by 4 and get 2 and -1. And what these special fractions, quote unquote, will become your binomials, factors. So 4 and -3 turns into 4y minus 3. 2 and -1 turns into 2y minus 1. Does it really work? Well, how do we check if we have factored correctly? You can always FOIL. So let's check. 4y times 2y, 8y squared. 4y times -1 is -4. Minus 3 times 2y, so -6y, so -4y minus 6y does give us -10y. And then -3 times -1, that's +3. The next question, I actually identify a pattern here. Do you see that pattern? Well, 4x squared can be square rooted. +9 can also be square rooted, so it's a 3. So if I have 2x, square root of this, times 3, I get 6x. If I double that, it does give me -12x. Well, we gotta make it negative. So that falls under that perfect square binomial pattern. Therefore, the factored form of this trinomial is 2x minus 3 to the power of 2. Don't worry if you don't see the pattern, because you can still use the product and sum method, like part D, to figure out this answer. In part F, 9x cubed minus 16x. So don't forget, common factor first is x times 9x squared minus 16. Can I square root 9x squared? Can I square root 16? The answer is yes. So I have a difference of squares. So to factor difference of squares, it will be the square root of the first term, 3x, plus square root of the second term, 4, times square root of the first term, 3x, minus square root of the second term, -4. In part G, I also see a difference of squares. So here you go. Apply that pattern. Square root of the first term plus square root of the second term times square root of the first term minus the square root of the second term. Then in part H, I can see that obviously 5 is a common factor. Factor that. And then you're left with p to the power of 6 minus 1. Sometimes a pattern like this is called a difference of cubes that can be factored further. But in grade 11, you can leave your answer like that, and you will learn about that rule more in grade 12. We're going to continue the next part of this factoring lesson in a different video.